that's fantastic, and it's very difficult to follow that. Anna and Peter have charged me with, well, in our Cabot Institute at the University of Bristol, we're interested in all sorts of things. I'm not going to talk about that. I brought a single magazine, if anyone is curious. What I am going to talk about is just the science of climate change. Things that I suspect most of you are familiar with, but I think the idea was, let's just remind ourselves why we're doing this. So I'm going back into my role as a scientist, not as a director of the Institute. And I'm going to break that rule with my first slide, only a little bit, because I just wanted to make 3 broader reflections that are somewhat within the remit of what this. I think it's important to recognize that climate change is not our only environmental problem. It's not our only problem in many ways. And if we don't acknowledge that, we're not going to bring everybody along with us. If we don't recognize that other people are worried more about their jobs, worried more about putting food on the table, worried more about the NHS, worried more about security, they're not going to come on a journey with us. We need to recognize that people have a lot of problems. What I think we should do a little bit more time in explaining is that climate change, I would argue, is not so much a problem in and of itself, but it's an issue because it exacerbates every one of those problems. If we're going to have a lot more heat waves, how sustainable is our NHS? And I can make many, many, many other examples along those lines. So I think we need to look at this holistically as part of how we view our society. The second comment is very much a scientific comment. I am a geologist, and I look at how things have changed in the past. And one thing that we know is that if you add carbon dioxide to the atmosphere, it stays there for a long time. If we decrease our emissions, that will slow climate change, and that is no bad thing. But it will not stop climate change. We only stop climate change if we become carbon neutral, just as you were saying. And then the final point is really more in Marxian, but I just felt obliged to say it, which is that, decarbonization is going to be hard. I honestly don't think that any household, any city, any town can really go it alone. We all have to go it together. But that doesn't mean that some organizations, some towns cannot lead and be examples. But also, if you're a leader, you will reap the rewards by being the innovators, being on the sharp end, not just of the new technology, but the new innovations, the new social structures. You will be the smart ones. And people will come to you for advice and wisdom. So let's just take a step back to the science then. Right. As I mentioned, I'm a geologist, so I always start with a few fundamental facts about climate change. There's things that we debate, there's things on which we're uncertain, and there are things that we know very, very, very well. So I'm just going to say a few things about what we know very, very well. Those are, I think, my first 3 points. And then a few things about what we don't know well, but we should still worry about. One thing we do know, climate changes. We have ice ages. You go back in time some 50 million years ago, there are palm trees and robust forests on Antarctica, around the Arctic Circle. Climate is not unchangeable. It will change. Now that little fact can be manipulated. Climate changes, so humans can't do anything. That is naive. That's like saying that what difference does it matter, if people get cancer or are murdered because people die? It happens. Not a terribly sophisticated way of looking at it. Climate changes, we know why. It changes because of how the sun acts, it changes because of where the continents are, and it changes because of carbon dioxide in the atmosphere. There's a few other things that come in, play a role, but those are the main 3 things. So I've got a little picture of the oil well there, That's the fossil fuel. It's sunset, so I'm also acknowledging the sun, and that is also important. But there is no doubt that carbon dioxide affects climate. And this is really fundamental science. I'm not just a geologist, I'm a chemist. All of chemistry is based upon some of our understanding that underpins how we know the greenhouse effect works. We understood this 200 years ago. In this paper, 120 years old, Svante Arrhenius speculated that burning fossil fuels would cause the planet to warm. I'm not saying that because we've known it for a while, but I'm saying it to underscore just how fundamental the science is. It is not exaggerating to say the science is almost as fundamental as our understanding of gravity. The other thing we know is what we've measured. Carbon dioxide increasing. 400 parts per million in the atmosphere. throughout most of the past several million years, it's been between about 170 and 280. It's a 50% increase since the Industrial Revolution. In my work, it seems fairly likely that the Earth has not experienced this much carbon dioxide for 3 million years. That's a big change. And we know it has caused warming. This is a graph of the sort of anomaly. Many of you will have seen it. This year is a bit of a milestone. It's been exaggerated by natural variability, but we have experienced what most people argue is a 1 degree warmer world because of CO2. And of course, what we agreed in Paris is we were going to try to keep it to 1.5 degrees. We're already 1 degree in. Okay, so these are the things that we know, and if you want me to elaborate or have questions, we can ask at the workshop, or you can ask me afterwards. But what are some of the things that we're worried about but come with more uncertainty? Because there are debates. A little statistical mess over there on the right side of the slide. But what that shows us is we know that carbon dioxide causes warming. There is legitimate debate over how much warming. A lot of people, a lot of climate skeptics try to make a lot of this. Let me put this in very simple terms. If climate is more sensitive to carbon dioxide, then we are way behind the curve and we need to start acting very, very fast, and we have a lot of ground to make up. If climate is on the low sensitive side, as some climate skeptics have argued, people who are doing legitimate science, I should say, people who are legitimately concerned and trying to tackle this, but they argue that the climate is not as sensitive and warming will not be as pronounced, then in that case, we just have to start tomorrow. Right? It's still urgent, it's just that we have a little bit more time. And by a little bit more time, I mean 24 hours or so. We really need to get going on this. If climate is less sensitive, we have a little bit more wiggle room, but we don't have much. And 2046 and 2050, these are our targets, no matter what the climate sensitivity is. Other questions are, how fast? We are adding carbon dioxide to the atmosphere faster than any time that we know of in the past 66 million years, probably faster than almost any time in Earth history. We don't know what will happen. We know that ice will melt, but how fast? We know ecosystems will have trouble responding, but they've never had to respond to a change this fast before. Big uncertainty, big uncharted territory. This is what we really talk about. What will be the impacts? Sea level is going to rise. The oceans will warm, ice will melt. How much? We all care. The Maldives cares, but we all care. There's a legitimate debate about how much it will rise, but it will rise. And more if we raise temperatures. What about flooding? There's a lot of uncertainty about things like hurricanes. We're not really quite sure how climate change will affect hurricanes. We're learning, but that's tricky. But what we do know is warmer air holds more water. When it rains, more water comes down. In the future, rain events will have more rain and we will have more floods. That's just physics. Unfortunately, ecosystems come with great uncertainty, and unfortunately this year we are learning that we are really already beginning to stress them dramatically. We are seeing one of the worst coral reef death events in our lifetimes. And coral reefs will recover over 10 to 15 years. But if events like this year happen every 4 or 5 years, our children will live on a world without coral reefs. They will not have enough time to recover. And again, our colleagues from the Maldives are seeing this happen. And they are seeing how it is affecting their fishermen and their food and livelihoods. And that sort of brings me to the last point. I actually grew up on a dairy farm, so this is the one that always concerns me the most. Given everything else, temperature, rainfall, ecosystems, great uncertainty about whether or not we'll be able to produce the amount of food that we need. These are really fundamental things, and they lead then to the really great uncertainty, which is the societal impacts. How do all of these things affect people? Will it be fair? Will it be just? How will it affect things like the NHS? How will it affect conflict? We don't know. What I would argue is that there is no uncertainty that these are risks. I'm not up here predicting a certain amount of sea level rise or predicting our food security will collapse. What I am saying is there is no doubt that there is a risk. And scientists do not disagree about that. I'm going to allow myself one opinion right here. My opinion, no sane society willingly exposes itself to that degree of risk, to the risk of hundreds of millions being displaced by rising sea level or drought or famine, to our food supplies being put at risk. That is why we really must act, even though we don't know for certain what will happen. The real question, why we're all here tonight, is how should we act? I think I'd like to leave with just one sort of positive thought. Climate change will affect all of these other types of issues, as I alluded to in the beginning. That means that addressing climate change is actually an opportunity to address so many other issues in our society. It shouldn't just be the elephant in the room. It should be a way to sort of catalyze a more creative way of tackling a lot of our other issues in a collective, holistic way. If we do climate change right, we can make our NHS more robust, we can make our economy more robust, we can really view this as a grand challenge that inspires us, rather than some terrible catastrophe that we must avert. And that's where I'm really excited about how Frome is tackling this, because I get the sense you're tackling it with a real spirit of optimism. So that's all. Thank you very much. Real pleasure to be here. Thank you so much.
If there were points that Rich made that you want to sort of clarify, and say we'll get time for more discussion later, but if there were bits within that anyone wanted to ask where
doing this, because I get the sense you're tackling it with a real spirit of optimism. So that's all. Thank you very much. Real pleasure to be here. Thank you so much.
If there were points that Rich made that you want to sort of clarify, and say we'll get time for more discussion later, but if there were bits within that anyone wanted to ask where, what was that figure about, or what was that graph, then go for it.
Okay.
Fine, thanks.
All good?
Have that opportunity. Totally clear, thank you.